That's cool. Hello everyone, welcome to today's stream. I'm here and I've just noticed actually my microphone is in the way. So yes, we have a rocket launch today. Very good. Really Rich, you're going to start off chat like that. Very good, very nice. Yes, very good, very nice. I'm just going to move my microphone stand a little bit. Oh, I'm really getting some bad green screen effect. Let me move over slightly, read the camera. So yes, we have a rocket launch. I think this is the actual rocket that we've got. So yeah, no, it's going to be quite cool. I'm just seeing what I should have a pop-up in the chat I think it's every couple of messages. So yeah, we have a rocket and it's taking off. It's a weather satellite that basically is going to be constantly going around the Earth in a fixed position called geostationary orbit. So let me turn the guy down at me here, moaning. So yeah, we've got that. It's going to be quite fun. This is a NASA rocket launch, not a SpaceX launch. So it's going to be quite different of a rocket. So yeah, this is actually the rocket. That's not the rocket. That is the solar panels coming out. So this is the goes west. No, goes east, even east. This is the east one. That's pretty cool. Right, so what I'm going to do, I'm going to put on the sound for you guys.
It will provide critical data over the northeastern Pacific, where many of the weather systems affecting the continental U.S. originate. It will monitor and track tropical storms and hurricanes in the Pacific Ocean. It will help identify and track wildfires across the western U.S. It will assist in search and rescue efforts around the U.S. and its surrounding waters as part of NOAA's SARSAT
so there we go.
And it will help monitor and track weather phenomena that impact the western U.S., like dust storms, monsoons, marine fog, atmospheric rivers, and more. The GOES series of satellites supports NOAA's mission to provide secure and timely access to global environmental data and information from satellites and other sources to promote and protect the nation's security, environment, economy, and quality of life.
Yeah, sick.
GOES-T's instruments will gather data that can help in so many different ways, as you just saw. For more on that, let's hear from NASA's Leah Martin.
Thanks, Megan.
Oh, look at that,
I'm
the
here with
VAB.
Pam Sullivan, NOAA GOES-R program manager. Pam, thanks for joining us today to give us some insight onto this mission.
Oh, it's great to be here. Thanks for having me.
So we've heard that there are 6
It was
advanced
deleted
instruments
by
on
the-
board GOES-T. Can you tell us a little bit about them?
Sure, let me tell you about our most revolutionary instrument, the Geostationary Lightning Mapper.
Nightbot,
It's actually
no
the first time
way.
we've had this capability on orbit, and this instrument
Nightbot,
is watching the Earth,
why?
taking pictures
Why?
500 times a second to look at lightning. And because it is
My
a new
first
instrument,
stream with
we're actually
Nightbot.
learning new and interesting things about lightning as a phenomenon. For instance, we've seen that large wildfires can generate their own lightning.
That legit
And
is the
GLM
best thing
has
ever.
also shown us that lightning
Martin, you
strikes
just
can
got
be
done
really,
by
really long.
Nightbot.
For instance, GLM recently measured a
man, I
lightning
need to-
strike that was more than 470
I don't know
miles
why
long,
this part
stretched
here
from
is
Texas
not-
over to Mississippi.
Wow, and so
Okay.
having that
Is it
type of
because of
information,
that?
500 images per second, that's almost like having maybe like a
500
stop
images
motion
per
film.
second.
What can we do with that information?
That's
once we have
mad.
it?
Yeah, well, the important thing, of course, is what the forecasters can do with it. And they use the GLM data in conjunction with advanced baseline imager data and
I
and
have
some other data.
Nightbot now,
But
yes.
they
As
look,
you can see,
when they're
the stream
wanting
has
to see if
been
the storm is
elevated a little
intensifying,
bit. I've
they're
got
looking at that lightning signature,
ticker
and they're looking
down
for what they
below.
call a lightning jump. When the
I
amount
can
of
also
lightning
put
strikes increase
YouTube chat
dramatically, because that indicates that the
into
storm is likely to be
there,
becoming more
down below
severe
me,
and may spawn
which
dangerous tornadoes.
I need to
Oh,
update
wow.
that.
So we talked a little bit about
Yeah,
the
no,
location,
it's,
that this will become
I've got some proper
a
stream
satellite that
elements
observes
now.
the Western Hemisphere.
really,
What part? Why is that location significant?
Yeah, specifically, GOES-T is going to go into
Working
service
this
as
all
our
out.
GOES West spacecraft. So it'll be stationed over the equator, a little bit off of the west coast of the U.S.
Right.
And as you know, most of the weather in the U.S.
see if
moves
that
from
works.
west to east.
Right, I have a problem right now. I put the wrong link in. Okay. Right, I put the wrong link into site because I'm an idiot. Right. That needs to go down there. There we go. Properties. Right, this should be better. There you go. You have way too loud. Who's way too loud? Me? Or that random noise that just happened? Oh no, I sound okay. Oh, I hear the fridge going. Well, darling, do we have any snacks? No, we eating them all. Okay, I'm licking the Skittles from up here then. The noise, yeah, I didn't mean to do that. I may have pressed the wrong button. Oh, squashy, yeah. Huh? I'll buy some more tomorrow. I don't know. You need to add Nightbot codes. What do you mean Nightbot's codes? I can actually add you as a moderator.
Maybe. It sounds really bad, but I read just his buttons. I'll replace them tomorrow.
Yeah. Well, I'm gonna open these underneath the desk, so they're not so loud. I can't believe mine was putting a 5-minute time out. That is so funny, Mark. Oh. So yeah. I can actually. Oh yeah. I've actually, I know what you're on about now. Yeah, like you can request music being played. You can request like shout outs and shit like that. Yeah, that I am working on that, Rich. I didn't actually know it was called Nightbot Codes, but yeah, I am working on it. It's just getting it all set up, and with YouTube being YouTube. Why is it just that part there? This is really annoying me. I've got a really itchy nose. There you go. Oh, look, I can see it now. I'm pain in the backside. There's the... Oh, okay, the dog's been in here. Do you know, I'm actually looking at it right now, Rich. I've got Nightbot on my right screen. Commands. Oh. Someone just slammed the door outside. Right, I'm going to put their sound back on. Right. Get over here.
The first is the advanced baseline imager, or the ABI.
There we go.
We're able
See,
to
you guys have got it.
from the thermal signatures
Some
from the
streamer
fires, and
I
we're also
know
able to
will
detect
do
the
something
smoke
like
and track the smoke with time in
Facebook,
order to
and I will
issue
send a link
notifications
to
and warnings
Facebook
the
page
public.
or
The
Twitter.
second instrument is called the Geostationary Lightning Mapper, or
Cool.
the GLM. The GLM is important because often
Yeah, I'll work stuff out, Rich. I've got. I'm getting into it now. So I am gonna have some really cool ones.
But a new satellite called GOES-T is poised to replace GOES-17 in the GOES-West position. Once it
So I
reaches
think I've
orbit,
got
GOES-T will
one.
be renamed GOES-18, and it will provide the same.
Let me see if this. I wonder if this works on me. So I'm going to post it in chat.
As well as detect lightning that can ignite a wildfire in parched vegetation.
This
Is
current
Nightbot going to do it?
goes is the fact that we can do rapid scans, higher resolution with higher sensitivity.
It's not.
And include things for the
Right,
first
I'm gonna
time
remove
like
that.
Lightning Mapper and the ABI instruments. I don't think we could imagine having.
So I've got
those
Nightbot to
capabilities
set
we
that
absolutely need it.
every.
The
How many
National
comments? 1,
Interagency
2,
Fire
3,
Center
4,
is the
5.
nation's support center for wildland firefighting.
6.
GOES is an eye in the sky.
Right,
It's giving us a hemispheric perspective with those
give
16
me-
and 17 without having those two
Yeah.
satellites up there constantly
1,
staring,
2,
constantly
3,
monitoring,
4,
constantly providing us with information.
5.
We really have just a big gap.
6.
We would lose a lot
So
of
every
our
6
capabilities
comments,
to
I've got it set
understand the
to.
environment, to see the interaction of the fires with the atmosphere and see how
Well,
the
it's gonna
atmosphere is
be
impacting the behavior of
Pretty
the fires.
cool, I hope.
With those being able to
I mean,
look
the
at
tickers.
United States every 5 to 10 minutes, we're getting a much more real-time appreciation for how fires are behaving because of the ability of the GOES satellite
Oh,
to detect
Martin.
heat from the fires.
Nightbot hates you, does it?
Kevin, we were talking earlier, and you told me that oftentimes GOES satellites, even at 22,000 miles above the Earth's surface, they can sometimes detect fires before people on the ground even know that they're there.
Absolutely.
That's so impressive.
It's an amazing capability, absolutely. And we heard from our National
No,
Weather
you might be able to hear the baby crying.
Right there, that's a great example of how it happens. National Weather Service meteorologists are able to view an area that's
Right,
not
actually, I want to
populated,
see
but
if this
they can
works.
see a heat signature
So,
and actually
I've been
detect that
like
fire. And we
really,
found out
really
to the tune of
organising
80% of
all
the
my
time,
equipment.
the first one's actually
So
called
I actually
and let
have
fire responders
a new
know that
camera
there's a fire that
view.
has just started
Oh
or
god,
is
the baby's really going for it.
ongoing.
So we know GOES
So,
satellites can
I
help
go to
National
screens,
Weather Service, fire
and I
officials,
go
as you said,
GoPro.
but I didn't know
Oh,
that
typical.
we use GOES satellite
I haven't
data
turned it
every
on.
day.
every single day. Anytime you open up your phone and you want
So,
to do the forecast,
here we go.
you're
Let's see if
opening
this
up an
works
app,
now.
a weather app. That's exactly what you're doing.
Okay.
You're actually using GOES information.
I have.
That GOES data.
You can see
going
all my
directly
screens. You
into
can
the
see
models
how
that inform
messy
what the
this is.
conditions are gonna be.
But down here,
Fascinating.
I've got something special.
I had no idea. Here I am just looking
And ta-da! We have a new drone.
We're now L minus about
I'm just waiting for new motors because these motors are actually
it's about time for that
broken.
launch manager poll you talked about.
So we have a new drone.
It sure is. And that poll, which is
yeah, it's going to be
L minus 13,
a lot of fun to fly.
You got an update from the launch weather officer.
So yeah, that is good. This works really well. I'm happy.
They talked about the winds. They're still
I've also got
but the clouds have dissipated, so we are
another
now at 90% go for launch.
90% go. T-minus 13 minutes.
But Mick still got a 10% because we are watching those winds.
Yeah,
so,
as you can see in the forecast there, where Megan and Kevin are, the winds are still here on the ground, blowing pretty good. The team is continuing to monitor those, but yeah, I'm glad to hear that 90% go.
Turn this round.
Upper level, and they will remain green through 22.
Right, here we go, and then let's see if this works. Right.
And then when we get a later update, should we need it.
Listening to
looks like we have very
I haven't actually added this one to my Elgato yet.
Great for weather. We've had a really good
Dad's birthday present, perhaps.
And very little activity on the range instrumentation. So with that,
and there you go. We have another view.
GOES T launch poll.
This one, courtesy of my phone.
NASA CE is go.
So what we can do is
SMA.
there you go. So we got a phone. So if I take the phone off, oh no, there you go. That's that camera. And then we got GoPro.
Copy SMA.
Oh, we've got on no goes.
SMD is go.
Copy SMD.
SMM.
SMM is go. Copy
We're fun in there.
And LSP.
Should be in the pain, is she?
No, she had a pain.
Oh, she had a pain.
Copy LSP.
Martin got banned by my automatic Nightbot thing because Martin put capital letters in the chat. I'll tell you later.
Milestone, and so now we're good to go.
Yeah,
Dad's
Chuck, that was
birthday
a very
present,
important.
perhaps.
Sorry, Daryl. I'm thinking of that because I
they're
did
behind the
hear
gate.
NASA LSP. When I was going to say there's Tim
You
Paul
can't.
at the end there because Chuck
Oh,
Duvall.
okay. I thought my shoes were down by my feet.
This will be his last mission as he just announced his retirement from NASA after 40 years. So this mission, Chuck, goes to you. Thanks for everything you've done and thanks for that go.
I don't know what you mean, Martin, about Dad's birthday present.
He did.
Yeah.
He did.
It's a long career. Well, congratulations to him.
I'm confused with that one.
Here we are with the rocket on the pad.
Oh, look at that. The ULA.
Special message from
Is it a Vulcan? I think it's called.
Popular and somewhat famous meteorologist. We're going to get to that in a second, but we'll send it back to Megan for now.
They're surprised.
And GOES T is one of many NASA science missions underway right now. Let's head back
I'm
to Leah to
super confused, Martin.
Hi, Megan.
Talk to me after the live stream about that.
Buchan, NASA's Associate Administrator for the Science Missions Directorate. And
Chantal, is there a car out the back? Okay, I thought so.
Absolutely. It's a year of science. Every year is a year of science, we say. You know, like we have an amazing number of launches ahead of us. In fact,
I love this guy's accent. It is so cool.
We have
so cool.
We have JPSS, and you see the
See that?
theme. It's
I can't
all
get.
Earth science-related launches.
I need light underneath my desk.
Psyche,
to shine that way.
First light of the James Webb Space Telescope, as well as many other, highlights this year alone.
Yes, and so many of the missions that you just mentioned are actually.
Yeah, see, I can take my ticker off like that. You can go off. That's actually a multi-stage
From the
switch.
beginning, NASA was about exploring the universe, but also
And then we
exploring and
have
understanding our
lovely
own
chat there.
Earth and providing service for that. And
I love this. It's
launch
just
today,
all coming
as well as
together.
many of the launches
It's
in the
really
future are
slowly.
precisely
I
like
just
that,
need
understanding our changing
to
planet, the
move
system of systems.
and have a
Everybody
better
we
system
love
for my green screen.
is right here. Our
which
entire history is right
is
here on
not
that
far
planet,
off,
so
hopefully.
we want to understand and help protect it as we go forward.
There we
The
go.
information that we
That's
get from
slightly
these
better.
launches, how will we use that?
So
I
the
think I
information we
know
get
why
from these
it's done
launches
like
we
that.
use to get a better
Let's see.
understanding in many
Let's see if I
areas.
can
Of course, understanding, for example,
wreck it during
about
stream.
the aerosols that are in the air. Where do they come from? We know they relate to precipitation in many areas, like how do they get transported globally? Maya, my daughter has asked.
There we go.
It's about pollutants, learning from space, how to predict those.
Still a little bit there.
Information
I
from
don't
my
care
daughter
now.
and the many
I'm
others
gonna...
that suffer from asthma and so forth. That's precisely each of them has an application like that. Set of understandings that we want to
but we're getting there. Once I have my green screen set up the way I want it, it'll be great.
Going to be available to the public as well.
Oh wow!
Absolutely, everything
we'll be able to get this all from
all over the science portfolio is information that is made public. We want scientists of all training levels, learners of all ages, to be able to look at this. But we also believe it's really important to trust the science. You should be able to look it up yourself and understand it. We think that's a really important part, and we flag that. We're actually moving from open data to open science. So we actually even make in the future the codes available that provide the actual predictions and the information that is there.
Incredible using this information in conjunction with other information to give
this
us
is going to be quite
possible.
cool. I
Dr. Zurbuchen, thank you so
don't
much
think I've actually ever watched one of these live. ULA.
We really appreciate you being here.
Thanks so much, Lee. Absolutely.
What did Perseverance launch on?
Thank you both, and now taking us the rest of the way.
I can't remember.
Countdown is Daryl and Nick, guys.
Look at the weather in Florida.
-7 minutes and 50 seconds
so
until
unfair.
liftoff. Welcome back inside the Atlas Spaceflight Operations Center, the launch team right behind us, working this launch. So far, things have looked really good and sounded good over the nets.
Yeah, everything sounded great. The team is continuing to finalize their work as we get ready to pick up the count at T-4 and sync up the L and the T clock.
I'm going to put a poll in the thing.
Launch conductor poll at L-7 minutes with Dylan Rice.
Bacon.
Looking forward to hearing all
What's the
goes
bacon?
The team.
I take it that's
you can look at the bottom
something.
of the screen. You can see the milestones as we
so yeah, guys, there's a poll in chat. Let me know what you think.
Just a few seconds. We're going to pull up the poll on the right side of the screen. Count it down.
Who clicked yes?
Status check. Receive. Terminal count. Atlas. Propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2.
Go.
Water.
Where's me?
Go. Sensor system. Propulsion. Go. Pneumatics. Go. LO2. Go. LH2. Go.
I put my iPad somewhere.
Electrical systems. Airborne. Go. Ground. Go. Facility. Go.
Go.
RFFPS.
Go.
Go. Flight control. Go. TCQ. Go. Operation support. Go.
I'm gonna take a picture of this chat.
Go. ECS. Go. Redline monitor. Go. Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief. Go.
Go.
Range coordinator. Clear to proceed.
Just think, like, we don't hear
You have permission to launch. Proceed.
anything like this. We don't hear the no going.
Set 21.
Used to be an Easter egg with Nightbot where if you type bacon, it says I have no idea what type.
Yeah, that was great to see Dylan choreograph that poll. The culmination of several hours of work by this launch team, and then
it's
hearing
really, guys, it's 50-50. Oh, jeez.
Very excited and happy here to hear that as we get ready to pick up the count.
Oh,
as we
man.
look outside at the rocket, we can see those.
Yeah, no, Nightbot's is looking so cool. So cool.
Amount of clouds. You don't see it here, but we're looking at blue skies. You can see some of them there. They're moving. That's representative of those winds. But as we know here in Florida, it's such a beautiful time of year in March. But Mick, 3 months from now,
yeah, what I'll do, Rich, is I'll find out like all the different codes, because I've literally only set it up like a couple of days ago. So it's only just well, actually, I ain't got my watch on. What's it, the first today? I literally set it up Saturday, so yeah, I gotta go through. Like, it's got song requests. There's an auto DJ.
Give us that information about
regulars.
what's going on. And we have one of the more popular meteorologists that you may have heard of send us a pre-launch message.
I can do giveaways.
Hello,
no one's eligible.
Jim Cantori from the Weather Channel Television Network, and I am so excited for the GOES-T launch. Meteorologists and weather anchors like
Top chatter, Richie Rich. 370 gaming.
But also to keep you and first responders safe during severe weather events. Accurate and timely forecasts are crucial, and that's not possible.
Martin, I can actually review your comment in caps, and I can actually
2, 1.
Oh.
Mark.
And there you have the single.
Okay, I thought they were launching then.
To the left top, and the T clock on the right hand side.
Yeah, I can actually review your comment,
we are starting up
and I can actually ban you from chatting in chat altogether.
Here, the team's going to finish
That's
tanking
mad.
and topping the vehicles, securing everything, getting things to flight pressure.
I'm gonna
getting
sneeze.
The ordnance control unit armed, the
I'm
flight
gonna turn
termination
mic
system
off.
armed, getting the vehicle on internal power, which we heard a little while ago that the spacecraft
There you go, I'm back.
And on internal power, ready for today's launch. So we'll be finalizing all these steps, the United Launch Alliance team that we talked about earlier, and they will get GOES-T ready for a liftoff.
So we have a 67% vote it will go boom.
See down towards the bottom of the rocket, those two
Just think, we've literally got
2 on this side, 2 on the other.
probably, I'm saying around July,
is going to provide a lot of performance with
July, October, September, that time we will have the SpaceX Super Heavy launches, which is going to be mad to see. Like literally, there's just up the road from here is SpaceX's 39A where the space shuttle took off from, and like all the Falcon 9s take off from. Just next to it, they're going to build basically the launch tower from Boca Chica there. And they're already, like, I've got literally photos on my phone of parts of the tower already being delivered. Like, it's mad. It took 13 months from design to completion of the tower and, like, the ground facility. Stage 0, as he calls it.
159.
Oh, 159. Yeah, today's drink is KA Fruit Punch.
150.
I don't like this one as much as the others. Oh, it's a Centaur rocket. Oh, it's an Atlas. Okay. Atlas 5, isn't it? Is V5? I can't. I don't do Roman numerals.
To finalize all preps as the vehicle is getting ready for
I think so. What was GTA 5? Yeah, V.
SCS count started.
So this is an Atlas 5.
Reduce ECS for launch. Roger.
110. Vent valves locked.
Let me move my iPhone cable out of the way.
Securing everything to secure that boil off. We should now be coming up on the last call for the range.
1 minute.
Rock, report range status.
Range green.
Oh, hey.
Range, Daryl. So everything looks good this morning. Last but not
very
least,
hazy.
To flight pressures and then hear that last status.
And this morning, it's not bloody morning. It's 4:30. Oh, just gone 4:30.
To a shot of the rocket. Just a few
40 seconds.
Stable at step 3.
And there we verified that all pressures are good. And
nice.
Stable at step 3, ready for liftoff this morning.
28.
Verify ECS reduced for launch. Verified.
25.
Here we go, guys. Here we go.
Go Centaur. Go GOES-T.
And here we go.
I think Centaur is like the boosters around.
The final seconds now.
Here we go.
9,
8, 7, 6, 5, 4, 3, 2, 1. Lift off.
And lift off.
Apparently, like, this rocket just goes. It literally, it's not like a Falcon 9 which takes off kind of slow. This apparently hauls ass.
Okay.
Look at it. It literally is going. Holy cow. Like, a Falcon 9 is a lot slower than that. Holy shit. That's mad.
We have passed through Mach 1. Vehicle is now passing through Max Q, maximum dynamic pressure.
Jesus Christ, only 53 seconds in. Let's hit Max Q.
Atlas is 7 miles in altitude, 4 miles downrange distance, traveling at 1,900 miles per hour.
That is mental.
RD-180 is now throttling back up.
So we should see the boosters like just chuck
Back
off.
the throttle to reduce
Now at
the stress
75
on the
seconds
rocket.
into flight, Atlas is 13 miles in altitude, 10 miles downrange distance, traveling at 2,700 miles.
Literally, in the space of like 20 seconds, it's just done like 9 miles sideways.
Now at 90 seconds into flight, ULA's Atlas V rocket weighs now just 1/2 of what it did at launch, burning propellant at a rate of more than 2,600 pounds per second.
That is
10 seconds.
mental.
Solid rocket motors on the side. Cut off.
Let me just...
Beautiful shot from space.
SRBs have burned out as expected.
There you go.
And we see a good SRB jettison.
So I wonder what happens with... Because there's solid rocket boosters.
Steering.
Here in a few seconds, they're going to throttle back up.
Vehicle performance looks good at this time.
This is
now
crazy.
35 seconds into flight.
Damn. You have another squashy.
The RD-180 has throttled down slightly.
Look at the vent.
Vehicle performance continues to look good at this time.
Or is that the exhaust plume?
Stable and Atlas booster battery voltages remain in their expected ranges.
See, what's weird is you hear other rocket companies talking about batteries and stuff like that. You never hear SpaceX talking about batteries or, like, do they have, like, massive battery packs in them or something? A question I've always wanted to know. Like, what goes into actually making a rocket? Not just, like, the actual rocket parts, but, like, to power it and that.
We have just over 1 minute until BECO.
Oh, bloody hell, 1 minute.
We're now seeing the RD-180 throttle limiting to maintain a 2.5 G acceleration limit.
Payload fairing jettison.
Standing by for payload fairing jettison.
Oh, okay. Oh, what? Oh, wow.
We've seen a successful payload fairing jettison.
That was cool. You actually saw, like, the flex of the fairing.
RD-180 is throttled back up now.
I've never seen a fairing go off while it was still moving, like the first stage.
4.6 G acceleration limit. And
So that's what it looks like at the moment. So the fairings are now...
And you're looking at animation now.
We've seen that the Centaur has begun its boost phase chill down sequence.
Oh, I think everyone was wrong on the, you said yes.
Booster about to cut off.
Oh.
And BECO.
And I think now we'll go to...
Standing by
oh, wow.
Separation and a successful stage separation event. We've seen pre-start on the RL-10.
Go. It'd just be like a...
And mass 1. We have ignition for the first part.
Oh yeah, it's so the reason why you don't see a flame is because it runs off hydrogen, and hydrogen burns clear. So that's why you can't see any flame.
See all that and listen to Rob Kesselman call that flight. The first stage performed very well this afternoon, and everything's looking good. Those gyms.
Rich, I will ban that saying. I will put that in Nightbot.
Yeah, those Gem 63s performed well.
Rich, it will put you in timeout.
RD-180 performance well. What I really liked was when we saw the payload fairing come off. That was a great shot from the camera. Saw the payload fairing come off, and then most people probably noticed that little half cylindrical come off after payload fairings.
Yeah.
That was what we call the Centaur forward load reaction deck. Because the fairing, the 5-meter fairing, encompasses both Centaur and the GOES-T satellite, there's a load ring that's inside the fairing around Centaur to help keep that 5-meter fairing from flexing. So that's what you saw when you came off there.
And the engine response remains nominal.
And so
word from the trajectory and performance group that booster performance was as expected for the booster phase of flight.
All right, we're going to keep an eye on this burn and listen in. But in the meantime, we'll send it back to Megan out the hostess.
Nice.
If you're just joining us, welcome live to Kennedy Space Center in Florida, where we just saw GOES-T launch from just behind us at Cape Canaveral Space Force Station. And guess what, everyone? I just found out that this was Kevin's first launch.
It was.
How was it?
Well, no, he's not launching.
Almost a proud moment as an American, 20-year Air Force vet, and to be able to see this was awesome.
Good old Nightbot.
Absolutely awesome.
Yeah, I'm so glad to
Sticking in
be here.
there.
It was very fun to watch you react. Like you were like, you were like a kid. Like, oh, I have to see this. Oh, wow. It was
Okay,
great.
kid.
It was great. So what's
Missed
next?
launch yesterday.
Well, the wonderful thing about this.
Oh yeah. So there was actually a rocket launch yesterday from New Zealand, Rocket Lab. But I actually missed that because I didn't even know that it was going, because I actually had Twitter on mute. So I missed that.
That the images are correct, all that kind of stuff has to work.
And GOES is NOAA's latest
Let me
weather
just see what
satellite. As
that
we've
was.
said,
Oh my
we've
God.
been launching GOES satellites together for nearly 50 years. I mean, there's been so many
Something's
advancements
fallen
made.
over in the kitchen.
There have.
Set my
I
bin
like to
lid
remind
off.
people that, this particular
I thought it was a
satellite
dog going for
is really an evolution
a bit of food.
much like cell phones. Or when we talk about, hey, do you remember when we used to use landlines and rotary phones? Well,
I remember
think about
landlines.
The leap we've taken from then to the cell phones and the capabilities that we have, much like that with our satellites.
Yeah, I know. I feel safer knowing that GOES satellites are up there. And now I'd like to bring in NASA's Leah Martin, who got to watch the launch with our agency's Deputy Administrator. Leah.
Hi, Megan. Like you said, I am here with Pam Milroy.
Oh wow, look how windy it is.
And what did you think of
Martin,
the
we've been in that building.
It was exciting, and it was.
Rich,
I
did
don't
you
know, I always
go in the
feel this electricity.
VAB?
When a launch goes up, you're like, wow, people can do this. This is just the power and the majesty of it as you see it lifting into the heavens. It's always exciting.
Into the heavens.
Hours and hours and months of work that go into it. Absolutely. So, NASA's vision is to expand knowledge for the benefit of people here on Earth. That's the heart behind everything that we do.
So, Rich, did you go in the big building
This mission is a
at
great
Kennedy
example
Space Center?
of our mission.
Or did you just did we just go on a tour around,
Powerful things that we do at NASA
like all the
is
launch
we
pads and
partner
that?
with
Because
others
me and
to
Martin
maximize the benefit
have
of
actually
the
been
things that we
inside
do.
where we saw
So this mission
Space
to
Shuttle
launch
Discovery.
the GOES-T satellite will enable us to have cutting edge capabilities that are looking down on the western hemisphere, the western part of the United States, to
Oh, do you want to say
ensure that
actually
the
funny,
data
guys?
that goes into the
You
NOAA
might be able to hear my
models
computer
around
whirl a little
weather
bit more,
are, optimized,
because
they're
you're not going to see it very well. But
up-to-date,
here's the
will
side
affect
panel.
people's lives, whether it's farmers or protecting from wildfires.
I was having a bit of
But what's
overheating
interesting
issue.
is we're also going to take that data because
I was
we
trying to
have
render
Earth scientists
a
who are
4K
our Earth as a system
hour and something
climate
video,
far out into the future.
and
This isn't an operational
yeah, let's
weather,
just say my
which is
computer
what
got a bit
NOAA's
hot.
mission is. They do it very well.
But I now know
We take this
that
data and we also use it
taking
for
off the
benefit
side
of
panel
science.
solves all that.
So it's a really synergistic partnership.
It's
And
mad.
you just mentioned climate change and monitoring the changes because that is a priority for NASA.
It is. It's one of our top priorities. We are already doing a significant amount in this area. Earth science and looking at our own Earth has always been an important part of our science mission. Interestingly, we also study other planets in the solar system, such as Mars,
I'm looking
which we
at
believe was
what it
once
says
wet
underneath the NASA
and had
logo.
more of an atmosphere. And so the question is, how did it get
It's
the
actually
way
got like
that
the
it did?
apogee and
And how do we
perigee
make sure that does not happen to our
altitude.
planet? So it's a critical part of our
So the
our
apogee is quite high.
Well, we're hoping that the information that we get today
232
can feed into the future missions of
kilometers.
tomorrow. If nothing else, we'll certainly know.
But obviously the
weather.
perigee
Pam, thank you so much
is
for joining us today. We really appreciate
minus
it.
because
Thank you.
it's still not going fast enough to make a full loop
Thank you, Leah and Pam.
around
and
the
Kevin,
Earth.
GOES-T doesn't just forecast the weather. We've talked about this.
So
a little
it'd be,
bit.
there you
We've
go,
talked
now
about how
just
it
jump
monitors the
to
atmosphere for fog fog, dust storms, and smoke, and you know, especially for wildfires.
This
but what
is
about
pretty
like
sick.
smoke and ash?
I quite like seeing the apogee and stuff like that.
Absolutely. This past
They've
year's
moved the
been
NASA
kind of
logo.
a
It'd have been
revelation
good.
in our capabilities to view volcanic eruptions. In particular, probably the most spectacular example would be the Tongan one. But what we also have is another example in the Caribbean where you can see not only the amount of ash that goes up, but the area that it covers.
That's mad.
And as a result of that particular hazard becomes an aviation hazard in particular.
Yep.
See all the smoke there, you know. Weirdly enough,
not
2
smoke,
years
it's
ago, I was
ash.
traveling in the Philippines, and there was a volcanic eruption there, and we had to ground hundreds of flights because of it. So really, GOES helps decide whether or not it's safe to fly.
They do. Again, NOAA's partnered with the FAA, and they provide them with those volcanic ash, both forecasts and projections for where that ash could go.
All right, we're now approaching another milestone in the ascent. Daryl and Mick, back to you.
Thank you very much, Megan, and we continue to burn, continue to get good numbers as we monitor the flight of the Centaur and GOES-T.
Yeah, things are looking really great on this flight, and coming up on MECO 1 of that Centaur engine as Centaur continues to perform normally. We've heard pressure.
So it's got to do.
Has gone open loop.
Here in about 10 seconds, we'll have the
Standing by for the end of the burn.
So you can see the perigee altitude has now just gone up.
There you go. That completes that first burn. And so now we go into about an 11-minute coast phase.
At this time, the GOES-T spacecraft and ULA Centaur upper stage are in an unpowered coast phase that will last approximately 11 minutes. The coast allows the vehicle to move to optimal orbital position in orbit prior to beginning the second main engine burn.
Cool.
And what you're looking at is animation that is tied directly to the telemetry we are receiving from the rocket.
Yeah, the team is using all the vehicle telemetry to.
So what we're going to do while we wait for this 11 minutes, we are going to check out my new game quickly.
Is really good, and as we heard Rob Kessel say a minute ago, this
approximate 10-minute on the right screen
park orbit around Earth
for the minute.
As we coast around to get into the
till I get this turned on.
For that second burn, which
it's set up.
Send us on our way towards.
So this is my new space game.
A longer burn, and then we've got Daryl.
Oh, shut up, me off. Been a long day at work. So this game originally was on.
The bottom of your milestone list between MECO 2
let me turn their voice off. Cool. So we're just waiting for bloody Space Simulator to get update. Here we go. But they're quite cool. Right, preparing. Oh yeah, the computer's going to go a bit funny right now. There you go. So what I'm going to need to do is turn off. Right, I'm just going to mute them, and then everything's all going to go weird because at the moment this is a early access software game. So, here we go. Move my things that way. So, what we're going to do is we're going to quickly... Oh, I keep forgetting this happens. Okay, so it's going to flick one more time. We're just going to swap screens. Take that off. So here is my game. So this is it. This is early access game. It's awesome. Like I absolutely love this. On I love it on the phone. It's mad on the phone. Let me just move them stuff out the way because I've got to actually get the keyboard out. So there we go. I've been playing a little bit. Playtime's 14 hours. That's mad. So, we're going to build a new rocket. So, build new rocket. And at the moment, this is just a stock sort of game. There's going to be like a career mode, there's a sandbox mode where basically you have all the space and all that. You're not limited to these little square bits. So, and you get like cheats and stuff like that. So we're going to whack down our engines. So, oh actually, I'm going to turn this on. So, I'm going to make a decent sized rocket. So we're going to go here, 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 and we're going to go one more. Now with these ones, sides, there you go, we can do this. We can do that. We can do that. And then we're going to put a topper on it. That's a nice little rocket. Side boosters. Right. And then we need to go back to 12. You stick that there. And we can zoom in. We're going to go 8 wide. We're going to do this. And then we're going to stick some more engines in there. That one. And that one. That one we're going to just turn around so it makes it look cool. Right, this one's an 8, isn't it? Yeah, cool. Right, and then we're going to have our main satellite on here. So, I'm going to get some structural parts. Actually turn off that now. So, let's get that. We're going to build off there. So, we are going to put a probe on there. Right. And then we're going here. We go one more to here. And we're going to put right. I'm actually going to, there's a bit of a click issue here. You have to click sort of just next to the item you want. Right. So, and then we're going to put a heat shield on this because I'm actually going to return it back to Earth. There we go. And then we're going to put some thingies there, what the solar panels. And then what we're going to do is we're going to put can I, oh yes, okay, cool, I can do this again. So there's actually a glitch you can do. So you put something over the top and then it will go blanked out, so you won't be able to do it. So you click both items, you just hold it, you move it a little bit, there you go, and now it's inside. So now we can put a fairing on it. So too small, too big, too big, I'm looking at the wrong ones. Wrong one. Right. Okay. Right. So we need a smaller one of them. There we go. And then we go here. That's it. There you go. And that is a rocket fairing. Pretty sick. Oh, great. And I just realised everything flicks. And I have no idea why. But yeah, so we are just waiting for that. I don't know why everything's just gone crazy again. But yeah, so we now back to this again. Now we're going to flick off it again because I'm going to press play on the live stream because for some reason the other live stream just went crazy. So here we go, last flicker thing. There we go. Right. Oh, they're just coming over to the
here.
They're just starting off the second burn.
Phase right now, heading over Africa, West Africa,
Africa,
across the southern coast there, and we've got a burn coming up in just about a minute.
Yeah, this second burn's very important as it'll get us out of this park orbit around Earth and get us on our way towards that geostationary orbit we want to head for GOES-T to allow them to do their science and protect us with all those instruments they've got for weather.
Boom. Yeah, no, it'd be quite funny if it went boom.
The Centaur on the left part.
I doubt it. It's such a reliable rocket now.
It chases the sun, Nick, chasing orbital sunrise here in just a few seconds.
As you can hear, I am literally still building the rocket in the background. Just getting. Hey, give me back my mouse.
Pre-start on the RL-10 coming up from Rob Kesselman. Data showing that RL-10 is getting ready to ignite for the second burn.
Locks pre-start on the RL-10. We have ignition. Nest 2.
Nice.
Main engine start number 2. We have advanced across the bottom of your screen where we have all the milestones listed. We're going to burn for about 6 minutes. As you mentioned, Mick, this is really hitting the gas.
PU has gone to closed loop control.
Yeah, absolutely. This is going to be the burn where we get GOES-T headed out where it needs to be. And
yeah, because the apogee
for that 3-hour
altitude is going mad.
Go and then get ready for separation. So still a lot to go from here, but this is a very important burn for the mission.
Going deeper into space, approximately 22,000 miles away from the surface of the Earth. Mick, I want to take you back. Of course, we know that this satellite here can have ability to map lightning. It's got high technology on there that's very valuable. But also, when it was on the ground, it could have been suspect, rather, I should say, susceptible. Sorry, susceptible to lightning when it was on the ground. But Launch Services Program developed some technology to help protect it, and I was fortunate to go out to the pad. This is something that you do a lot. Go out there to the launch pad, but I was invited to go out with one of LSP's young engineers to share and install this equipment that helps protect against delays. Let's check it out.
Hey, Alex.
Hey, oh man, I'm sneezing a lot lately.
Me out. So this is it.
This is it. This is the PLI.
The NASA Portable Lightning Instrumentation. I see it right here. You're going to take it up there all the way to where the top of the rocket is?
Yeah, right around where the payload fairing is, level 5.
All right.
That's where we're going.
Well, you need a hand?
So that's like a lightning detector thingy.
Now that we're inside the VIF and we're about 13 stories up, tell me a little bit about this box. You've got some, looks like some sensors here.
That's right. So we got the current probe, which is over near the rocket, and we have 3 more sensors over here. This one is an electric field sensor. This one up here is a magnetic field sensor. And this little one over here, that's a GPS antenna. That's how we get it, make sure our data stays synchronized in time so that we can correlate that data to all the other lightning detection networks in the area.
That's pretty cool.
What happens if there's a lightning strike somewhere nearby? What does this do?
So if it's close enough to cause any interference in this area, these field sensors will pick it up first. And they'll cause the entire system to take a snapshot of that data and record it.
And how is that helpful?
We'll know what the peak of it was. We'll know how long the transient lasted.
So,
we'll be able to calculate how much energy traveled through there.
we'll have a lot more
I
information.
think we might have a live stream on Thursday now as well. Starling. Didn't see the time of it though. Right. Well, while they're being boring, we have a rocket here.
Towers out there, and ULA tells me that
So,
that protects the rocket when the lightning strikes. So why do we need
shall
to
we
Yeah, so this is
set this rocket off? So there it is. It's got separation modules. It's a 3-stage rocket. And we can just go launch. Oh, I never added parachutes. See, it's good. This thing actually reminds you to do stuff like that. Because I'm constantly forgetting to put like a heat shield on something or like anything like that. Right. Oh wow. It's up there. Very far away. Right. I think.
It's great to have me out there at the pad. But
Here we go.
I mean, really helpful.
We have
lightning strike. It was
main engine
inside the
start
goes
2.
Yeah, Alex and the team.
Which I don't understand. Is it?
Studying this for years, and they
It's
came up with
separated, so
CLI
actually
work
it's second engine.
And working with our commercial partners,
Start.
they've been able to install it, like you said, on the VIF for the Atlas V mission. And as
It's just
mentioned,
wording's
we
very
actually used
different.
Mars 20 to help us verify some information, so we didn't have to go back and retest
Right.
anything. And it actually.
We're gonna
saved
go
a lot
to
of
this
delay.
burn.
So,
We're gonna
the
try and
hardware is
get
great
into
with
orbit
what,
with this.
what, we have involved
I'm
in
gonna land it,
Especially important
and then
for
that'll be the stream over.
like Mars, where you only had
Oh,
so much time
there you go.
to launch to make it to the planet.
It's still
But
burning.
we are in the midst of a 6-minute burn. We're about to wrap that burn.
Oh,
up.
there you
The
go.
GE
We're gonna
is on
finish this burn. We're gonna finish this.
We're looking at animation of the Centaur upper stage. We're also looking to Ghost
Yeah,
spacecraft,
29,
represented by animation. Just a few seconds left in this burn.
30,000 kilometers.
And we have MECO 2, second stage main engine.
32.
There you go. We have completed the second burn. Really
RCF
got
is now operating at 100% settling level.
That's mad.
really got away from the Earth, and now we're cruising pretty good speed away towards that stationary point where they want to get that.
Yeah, what is like the
Yeah, this is the moment we've been talking about for a little
like
bit, right?
speed of that?
3-hour coast that we're gonna have.
Yeah, there's a
Centaur
3-hour
do
coast, so
the,
I ain't
do
gonna
the
be
thing,
doing
head
that.
out towards that geostationary where they want to
Right.
get to, so we can have that third burn of the Centaur. And what we'll see on that third burn, Daryl, is that after that 3-hour coast,
Right,
Centaur
so what
will
we're
go
gonna
through its
do?
process again of pre-chilling the engine,
Jeez.
doing some things to get ready for that.
Centaur is
mission,
now
that
entering
very,
an extended duration coast.
Alright, cool. Right, now we go back to this rocket. So, we have sound, I think. Yeah, we have sound. Right. So, I've just put, if you look here, I've got like a checklist of things that are going to happen. Yeah, so there is our full rocket. I've not actually flown one like this before, so this should be fun. So, we have throttle on our shift and control button. We have ignition on the start on the spacebar, and then we got motion with E and Q. So, here we go, guys. So I'm going to zoom out a little bit. We're going to start turning. I actually think that both actually might run out at exactly the same time. So we are passing through 3,000 meters, 4,000 meters. It looks really stupid with the little engine pods. There you go, 5,000. I'm going to just check the map, see how well we're doing. So I'm just going to throttle down because we're about to hit Miko. There you go, when we hit 10. Now there is like full thermal temperature model on this. So literally if I was to whack it up back then, keep it going full speed. There we go, we can put that up full speed now. You would literally get like proper fire almost. Right. So we're gonna just add them into it. So we are going to leave it down. So now we have, oh crap, I may have forgot to turn the main engines off. Okay, we might still be able to reach orbit. So now we're going to break apart the fairing and release from the second stage. Here we go. There we go. Oh, look at all these particle effects. They're sick. Right, and then we're going to use our thrusters. So here we go. We're gonna play them. We're gonna get our solar panels out. Sorry, motion. Oh god, I can't believe. Look, our main stage is actually going further than we are. This is so unfair. There you go. Hopefully we'll still get into orbit. Obviously the second stage would have completed us into orbit, but a miscalculation in sequencing may have caused that error. Right, we are, I think we might actually get there. I say might, because like we're definitely pulling away. So there's the fairings and that just there. I cannot see the other parts of the rocket. Like they're way up there. And we are just about to pass there. We are getting into orbit almost. So we're looking for 1,600 and something meters per second to hit full orbitable speed. So we are almost there. Oh, I might need to use a different button now. Yep, there we go. I'm using a different button because we've moved around quite a bit. We are at 60 kilometers high. So that rocket that's just taken off is 30,000 kilometers high. It's just nuts. Absolutely nuts. Right, we might just be getting into orbit. Lee, your brother has gone quiet. Yes, he has. He's probably watching something else. Here we go. So this is my perigee. This is my apogee. This is my perigee. So You're almost there. Alright, we are officially in low Earth orbit. There we go. I'm going to stop it there. And we're going to see these guys burn up. I'm surprised he's not back after Tottenham were losing. Oh, a Tottenham plane, is that what it is? Right, so now what we can do is we can speed up. And here we go. Now watch this. You see the temperatures down here. They will burn up. So there's the other two bits of fairing. And you can hear the booms because they are actually disintegrating. Here we go. Let's zoom in. There you go. And that is that officially killed. So this is from one of the side boosters. This shouldn't take 2 seconds to burn up. There we go. Alright. So yeah, this is what normally happens with a rocket launch. They just re-enter, and because they're not heat protected, they burn up on re-entry. There we go. That's done. Right, now we got... What's that? Oh, that's one of them. Okay. I want that one. Cool. Right, so we got one bit of fuel tank left from the main stage rocket. So here we go. Well, actually, that's the second stage rocket part. So here you go. So this is still travelling almost 16,000 meters per second. It's mental, this game. There you go. Done. And we can keep switching to these, but they'll just blow up as soon as you click on them. And there we have it. We are officially in orbit. So we can do all sorts of things like spin it around, blah 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 blah, you know, all the cool stuff. So let's do a full loop or a couple of loops. Let's speed up time. There you go, 1 orbit, 2 orbits, and we'll come around to 3 orbits. And now we will decelerate once we get halfway round. So we're going to lower our apogee. So just after our perigee, we then bring it down. We want to come and land right back where we took off. So this is a very difficult thing to do. Is to actually land back where it came from. So I'm gonna go there. When do we actually enter? Oh god, no, that's way too early. Right, map. There we go. Right, let's get back on the map. Right, we're gonna all the way around. Right, here we go. So we're gonna stop here, and we're gonna do a full there we go, and then we want to, oh, RCS, no, I need that. Here we go. So we're just gonna now fold them in, because you know you don't want to be shooting through the atmosphere with I think we're gonna definitely overshoot here. So you can see we're actually slowing down here. Yeah, I think we're going to overshoot by quite a bit. But that's fine. We can, as long as we make it down to Earth safe. Oh no, here we go. So we are really decreasing. This is basically what the Draco thrusters do on the crew capsule and the cargo thing. They basically just slow you down, so basically you're going to re-enter Earth, and that's going to be very steep, but it's going to be so worth it. So normally you want like a nice gentle line, but we are coming down fast, so we are almost there. But yeah, we're not going to make the launch pad. That's fine. So in preparation, we have a little bit left. Obviously we've got this giant heat shield on the bottom of here. So now we are officially in the upper atmosphere. So this is where we start to get heating, which is below me. And we should, let me just, sounds are on. I'm going to turn the sound up a bit. Oh, cheats. Oh, you can get cheats. Okay. That's new. Here we go. So you can see the re-entry effect is really cool. So I'm just going to keep this going. And we're almost down. So we've already lost 5 kilometers already. So we're literally just re-entering. So that's 10 kilometers now, and literally look, I am just a tiny speck in there. But this is what normally happens when they bring a spacecraft back to Earth. It's super cool. And these heat shields are rated for like 6,000 degrees or something like that. So yeah, the Twin Towers should have been made out of this stuff. But here we go. So you can see our velocity has decreased a lot, like, and it's going down very, very fast. So yeah, we are getting there. So there we go, and soon we should have no re-entry effects. There we go. And now it's all about pushing sideways to end up going straight. Yeah, we're well off, but that's fine. I've never been good at landing that part on the launch pad anyway. Actually, on the phone I think I got a bit quite good. Right, so when we get to about 2,000 meters, we will open the chutes. Actually, no, we're going to go 1,500. We've got plenty. We've got 2 parachutes, so 1,500 should be great. So I can actually open them at 25,000. No. 2,500 even. So here we go. So 1,500. 3, 2, 1, and shoots open. So they half deploy first, which slows you down immensely. You can see how high we still are still are off the floor. So I'm going to fast forward with physics involved, which is good. And yeah, I can now release the heat shield. And now, yeah. And now that should destroy itself. And then once we land, we'll put the solar panels out, and that'll be it. So we are going to use our, there you go, we are on the ground, and we're going to put our solar panels out. There we have it. That is literally an orbit around. Bit of a mess up, but we managed to get it done in the end. Right, so I think that is where we're going to end this stream. The rocket is, yeah, still an hour and 30 minutes into its coast phase, so we're definitely not going to wait for that. Right. Yeah, I hope you enjoyed. Thank you very much for... You landed in the wrong place. Yes, I know I landed in the wrong place. I wasn't that far off, to be fair. Like, that one there is the launch tower, or the launch part. So I think I did very well for a game that, you know, I did mess up on. But, whatever. Yeah, so... Thank you very much for joining the stream. Hope you enjoyed all the new bits and bobs and all the fun that we can now have in chat. Rich, I will definitely get all the codes sorted, and I'll have a look at that tomorrow on my day off. Be quite fun to get done. Thank you very much for watching, guys. I'm Lee. Fly safe, land safer.